Hi everybody, welcome to another video in Math 1324, section 5.1, linear inequalities in two variables. So in this case, we just graph the inequalities. It's not just a linear function, but linear inequalities. So first, we have some basic here. So a line will divide the plane into two regions called half planes. The vertical line will divide that into left and right. A non-vertical line divide that into upper and lower half, and the line is called boundary line. So let's say we have the line, and of course it will divide into two planes called the half plane. If it is non-vertical, we have the one that is above, upper and lower. If it is the vertical line, we have left and right. The line is called boundary, and the regions divided by the lines is called half plane. Right. So when we graph a linear inequality, first we're going to graph a line. If it has the equal sign, we use a solid line. If it has equality, we use a dashed line. If it is equality is not included, if there's no equal sign, and then we choose a test point, preferably 0, 0. If 0, 0 is not possible, we choose something else. But the test point have to be in the region. The test point be not on the boundary. And after that, we shade the half of the plane accordingly. Maybe if it's true, we shade the region. If it is false, we shade the opposite. We see that in a minute. Right. I graph the linear inequality. Now we graph this. Now the easiest way to graph this is first we graph a line. It could be a solid line, it could be a dashed line, but it's a line. And a line is when we graph a line, we just need 2 points. And the better way to draw a line is if we have 2 points that are a bit further apart, and you connect. If we have 2 points are too close, it's difficult to draw a line if the points are too close. So we want the point to be a bit further apart, and also the point have to be on the grid, preferably. If the point is in the half of a decimal, half of a unit, then it's more difficult to graph. Right. So let's say we graph this. So first we'll just pick some value for x and then solve for y. First we assume that it's just equal to. So we just graph. If we choose x equal to 0, we have y equal to -1. And if we choose x equal to 4, x equal to 0, then we just have -1. Now if we choose 4, we have 3 over 4 times 4 minus 1. So 4 and 4 cancel out. That 3 minus 1 is 2. So we have those 2 points, 0 and -1. X equal to 0, y equal to -1. And x equal to 4, y equal to 2. And this one has no equal sign, so that's a dashed line. So that is a dashed line. If it has equal sign, that will be a solid line. And now we choose the test point. We can choose any point. We could preferably do 0, 0. Let's choose 0, 0. So when x equal to 0 and y equal to 0, I will substitute into 0 into y and 0 into x. So in that case we have 0 less than that case, so 0 less than -1. So we choose the point 0, 0 here. And what we have, we're going to test them. What we have here is 0 is not less than -1, so this is false. So test point is here, and it is false. That means the point does not belong to the solution. So we will go across the line and we say this is the solution below the line, because the point up above the line doesn't work, so it has to be below. So the solution is this region with a dashed line on the boundary. Right. So simple as that. Draw a line, use a test point. If it's true, we will say the region that containing the point. If it is false, we say the opposite of the line. Now let's graph to x plus 4y equal to greater than equal to 12. So for this, again, we graph the line first, then the test point, and then pretty much we go from there. So I'll choose some x and y here. So when the equation given in this form, it will be easier if we choose x equal to 0, then solve for y, and choose y equal to 0, and then solve for x. When x equal to 0, three times 0 plus 4y. Now we're just going to solve for equal because we need the point to graph it. So that's 0 divided by 4 on both sides, y equal to 3. And now y equal to 0. Put 0 in for y. We have 3x plus 4 times 0 equal to 12. And that cancel out, divide by 3 on both sides. X equal to 12 divided by 3 is 4. So when x equal to 0, we have x equal to 0, y equal to 3. And when y equal to 0, we have x is equal to 4. So we say the point x equal to 0, y equal to 3, and x equal to 4, y equal to 0. This one has the equal sign, so we will have a solid line. Right. Remember, when we find the point, we always assume the equal sign, so we have the point. Right, so this is a solid line. Now next is the test point. Again, the point 0, 0 is not on the line, so we can use that. If the point 0, 0 is on the line, we have to do something else, because the point not supposed to be on the line. Right, so we test that, and now if we put 0 in for x, 0 in for y, we have 0 greater than equal to 12, and that is not true because 0 less than 12, so this is false. So the point 0, 0 is here, and it's false, so we will go across the line, and the solution will not contain the point that we choose to test. So that is the solution. The solution is the graph, the half plane. Right, next, x less than -1. Again, we graph a few points. We have x equal to -1. So we only have x. Y we can choose any values we want to. X is -1, y could be anything, right? So that's what we choose. X equal to x equal to -1, y equal to 0, x equal to -1, y equal to 3. So this is the vertical line, and no equal sign. Now we test again. Test u 0, 0 when possible. Actually, we can test any point. we can choose 0 0 or any point that is not on the line. Again, let's choose 0 0 here. There's only 0 for x, so we substitute here. Is that true? 0 is not less than -1. 0 is greater than -1. So it's false. And we say it here. Now let's say it, suppose if we test the point -3 0, just an example, if we choose -3 and 0, -3 less than -1, so this one is true. So we will say the point that containing the point -3 and 0. Right, I said one point is enough. We don't have to do two points. Graph y equal to 2, greater equal to 2. Again, y is equal to 2. Now just look at the case when it's equal to y equal to 2. X could be anything. Yeah, just choose x to be anything. Y equal to 2, x equal to 0, y equal to 2, and x equal to -4, y equal to 2. It has the equal sign. So that is solid line. And again, we have the test point. Zero, 0. So put 0 in this inequality, and 0 is not less than or equal to 0 or 2, so that is false. So 0 0 doesn't work, it's false. So we go across the line and we set the region. So that's pretty much this section. In the next section, pretty much the same thing, but we do that for two equations, and then the procedure will stay the same. But with that, I just stop the video for this section here. As always, thank you for watching, and see you in another video in Math 1324.